Hello, Algebra Tours. Today we're going to be starting a whole new unit that is called rational expressions. And before we can do anything with rational functions or rational expressions, we first have to understand how to simplify um, rational expressions, which is the basic bare bones start of this unit. So what you're going to need today is your notes, notebook, pen or pencil, and a calculator. So our objective or learning target today, if you will be to learn how to simplify rational expressions. And the key here is accurately. And remember, when we simplify, we want things in simplest terms. That's why we call it that. So if you don't reduce or get things down into its simplest term, but you did part of it, that's not a true simplification. So our objective is to actually simplify everything accurately with rational expressions. Before we go too far into this video, we should probably start with what a rational expression is. And a rational expression is a fraction, or basically a ratio, aka a ratio. Another definition of it is a ratio of polynomials. Remember, polynomials are mathematical phrases, if you will, where we have numbers and variables raised to different powers. And so when we say that it's a ratio of polynomials, now we're saying that it's a polynomial in a numerator over a polynomial in a denominator. To simplify them, we're going to have to understand how to simplify fractions, how to correctly cancel things, and how to factor. So factoring is never going to go away, and in this unit it's going to become more important than ever, and that's why we started the other unit before this one, so that we could get our basics on factoring and understand factoring and become experts at factoring, so now we can use factoring to help us with rational expressions and rational functions. So with that, let's get started on some examples. Okay, so before we can start on actual examples, we should probably talk about how to simplify correctly. So we're working with polynomials in a numerator and a denominator, and whenever we've been working in the polynomial unit, we always bring it back to numbers. So let's first talk about how to simplify a fraction with just numbers. And I'm going to do the correct way first. So in the past, you've probably reduced this fraction by saying, oh, 10 and 12 have a common factor of 2, so I'm going to divide out a 2 out of the top and out of the bottom. 10 divided by 2 is 5, 12 divided by 2 is 6. Another way that you can look at this, even though this is probably what you've done, is we know that 10 over 12 is equal to, 10 is equal to the factors of 5 times 2, and 12 is equal to the factors of 6 times 2. And so that 2 that we're dividing out is a common factor of the numbers. So it's those 2's that we slashed out and we're left with 5/6. So the incorrect way to do this is to try to simplify without using a factor. So we know 10 could be the same thing as plus 0, and we know 12 could also be 10 plus 2, and then people want to slash the tens and say, oh, we're left with 0 over 2, which is 0. That doesn't work, and the reason why it doesn't work is because we don't cancel terms, we cancel factors. And so if you're adding or subtracting, that's not canceling a factor, that would be canceling a term. But we have to cancel our factors, or numbers that are getting multiplied. So keep that in mind as we go forward. All right, with that, let's try some examples. We have 4 examples today, and we're going to start off with this one. 40x plus 20 divided by 10x plus 30. So for each one of these problems, what we want to do is break it down into factors before we can start canceling the factors. So we're going to have to break it down using the 4 ways we know how to factor, which is GCF, grouping, trinomial methods, and difference of squares. Because I only have 2 terms in the top and 2 terms in the bottom, and neither of them are differences of squares, I'm just going to have to use GCF. So take out the GCF in the top and the GCF in the bottom. So 20 and 40 have 20 in common. They don't have any variables in common because 40x has an x and 20 doesn't. So if we divide out a 20 of that top, 40 divided by 20 is 2x. plus 20 divided by 20 is 1. The GCF of the denominator, so 10x and 30, have a common factor of 10. So if we take out a 10, we're left with x plus 3. So these are my factors, and the factors that we can reduce are the 20 over 10. We can reduce that to 2 over 1, but we can't do anything with the 2x plus 1 in parentheses or the x plus 3 in parentheses. And 1 times anything is just 1 times x plus 3 is just going to be x plus 3. So my final answer is going to be 2 times 2x plus 1 all over x plus 3. That is as simplified as I can go. There's nothing more that I can break down. Example number 2, we're going to have to use GCF again. So 2x squared and 8x have a common factor of 2 and x. They both share at least one x. So if we divide out that 2x in the top, we're left with x plus 4 all over. Now, if we look at 12x, there's nothing that we can break apart because it's just 12 times x, so that's just going to stay as my denominator. But notice how we have we have a lot of numbers getting multiplied. So on the top we have 2 times x plus 4. And then in the bottom we have 12 times x. So the common factor that the top and bottom have is this x. And because we're multiplying and these are all factors, we can actually cancel those x's out. 2 divided by 12 can be reduced. Here, sorry, let me grab my red color. 2 divided by 12 can be reduced to taking out a 2 out of 2 and a 2 out of 12 down to 1 over 6. And then we're still left with x plus 4 in the numerator. And 1 times anything is just going to be that thing in parentheses. So my final answer is x plus 4 all divided by 6. There's nothing more that I can reduce on this one. So that's my answer. Okay, number 3. So now we have 2x squared plus 10x all over 3x squared plus 16x plus 5. So start in the numerator. Let's try to factor the numerator. We're going to have to use GCF again. So 2x squared and 10x have a 2x in common. And if we divide out a 2x from each term, we're left with x plus 5. And then our denominator has 3 terms. And remember, in order to factor something with 3 terms, we have to use the trinomial method. So that's the set up 2 sets of parentheses. Now I have 3x times x gets me back to 3x squared. And now we have to ask ourselves, do we want the 1 to go here and the 5 to go there, or the 5 to go here and the 1 to go there? Well, my outside plus my inside has to get to 16x. So let's try this first 1, 5 pair. If we take 3 times 5, we get 15 plus 1. It looks like I should put 1 in the first set of parentheses and 5 in the second set of parentheses. So it wasn't the other way around, because if we took 3 times 1, that would get 3 plus 5 would get me 8 in the middle. So that's not the right one. And then because it's getting multiplied to a positive number and added to a positive number, we know this is plus plus. So now we have factored the top and the bottom. Here, I'll scribble this out so we don't get confused. So now we have 2x times x plus 5 over 3x plus 1 times x plus 5. So in my numerator, I have 2 getting multiplied by x getting multiplied by that x plus 5. And in my denominator, I have that 3x plus 1 in parentheses getting multiplied by that x plus 5. So actually what I have in common is this factor of x plus 5. And since they're factors and they're getting multiplied, I can cancel those. I can. Sorry, this is getting messy. So let me rewrite it. So now we have left in our numerator 2x, and then our denominator we have 3x plus 1. Well, there's nothing left that I can do, so I guess that's my answer, because we can't take anything else out of the numerator and denominator. We just canceled those common factors, which was an x plus 5 in parentheses. Alrighty, the last problem. So in the top, There are no GCFs between, or there is no common factor between x squared and a negative 49. But don't forget about difference of squares. We know that 49 is a perfect square, which means that's what we're going to have to use to factor my numerator. So set up two sets of parentheses, put x in the front of both of those parentheses, and I know the square root of 49 is 7, and then the difference of patterns, or the difference of squares pattern, is to have one of them be a positive and one of them be a negative. So that's the difference of squares. We took x and broke it apart, and then we square rooted the number 49 to get 7. One's plus, one's minus. Okay, in my denominator, I have 2x squared minus 4x minus 70. Yes, this is a trinomial, but let's make it easier on myself. 2, 4, and 70 all have a common factor of 2. So let's divide that 2 out first, which leaves me with x squared minus 2x minus 35. And now this is going to be a way easier trinomial to break up. So going on to the next step, my numerator is still x plus 7 times x minus 7. Then in the bottom we have 2, and now we're going to break up that trinomial. So I have 2 times this trinomial, x squared minus 2x minus 35. So what two numbers or two things multiply to get x squared? X and x. What are factors of 35, or two numbers that multiply to 35 and add to 2? Well, that would be 5 and 7. But we want them to add to a negative 2, which means that my 7 is going to be negative and my 5 is going to be positive. So I have two things getting multiplied in the top, those two sets of parentheses. I have three things getting multiplied in the bottom, and I have a common factor of x minus 7. So I can divide that out or cancel it out, and what I'm left with is my simplified or reduced answer. X plus 7, 2 times x plus 5. And that, ladies and gentlemen, is my final answer and my final problem. I want to thank you all for taking such good notes, and I shall see you soon.